Hi everyone. Today we are going to talk about a new type of function called inverse functions. Now, the primary condition for something to be an inverse function is first it has to be a function, and then it has to be a one-to-one function. So we are going to recall the definition of a function. Y is a function of x if for each value of x in the domain there is exactly one value of y in the range. So what it means is each value x can only map to exactly one value y. Now, new definition, one-to-one functions. A function is one-to-one if each y value in this range corresponds to only one x value. So it sounds like it's the order of x and y are just the opposite in the definition of a function, where each x corresponds to exactly one y, and then here each y corresponds to one x. So it has a one-to-one relationship. Algebraically, if f of a is equal to f of b, then a is equal to b. Let's do some example to get a better understanding of one-to-one functions. In example A, notice that the domain, or the x values, there are three values, -3, 1, and 2. And then in the range, their y values are 4, -1, and 0. So for each x value, I only see one corresponding y. So -3 only correspond to 4. Going to put an arrow here. And then 1 only corresponds to -1, and then 2 are only correspond to 0. Now this makes this a function. But for it to be a one-to-one function, the opposite relationship has to work as well. So 4 only correspond to -3, -1 only correspond to 1, and 0 only corresponds to 2. So because it meets both conditions, where x only corresponds to one y, and y only corresponds to one x, we say that this is a one-to-one function. Okay, so we all know that sometimes a relation can be expressed as a list of order pairs. So in example B, there are 3 order pairs. You can easily create this bubble chart as well if you want. So in the first one, where we include the x values, there are 3 values that I see. I see a 1, I see a 2, and I see a -2, as you can see here. And then for the corresponding y values, we have 4, 3, and 4 again. So since 4 is already there, we're just going to write it once. So I see that in the first order pair, 1 maps to 4. Okay. In the second order pair, 2 maps to 3. So far, so good. In the third one, -2 also maps to 4. So even though this is a function, however, it is not a one-to-one function, because for this y value has 2 different x values, 1 and -2. So we're going to put here it is a function, but not one-to-one. Okay? So sometimes a list of ordered pairs might not be given to us. A function itself, the expression of a function, or the formula of a function might not be given to us. Sometimes a graph might be given, and that's all the information that we have. In that case, we're going to use the horizontal line test. So horizontal line test, a function is one-to-one if no horizontal line intersects the graph of f in more than one point. Now, it sounds very similar to the vertical line test that we learned earlier. The vertical line test was used to determine if something is a function, and then the horizontal line test will use to determine if a function is one-to-one. So it has to pass both the vertical line test and the horizontal line test. All right, so let's look at example 2. Are these functions one-to-one? Or are these one-to-one? I mean, we have to make sure that they are functions as well. So in the first picture, let's draw any vertical line, and I can see that any vertical line that I draw it will only cross the graph at one point. So that's good. It is a function. Now let's draw a horizontal line. So if I were to draw a horizontal line, let's do a different color right here. I can see that it crosses through this graph at 3 different points. And for that reason, we can say that it is not a one-to-one function. In the second graph, let's do the vertical line test. So yeah, it only crosses the graph at one point. We'll get there. If you draw any horizontal line, it will only cross at one point only. So that is also good. So this is a one-to-one function for sure. In the third graph, if we draw a horizontal or a vertical line test first, you can see that it crosses the graph at 2 points. So it's not even a function to begin with. So it can't be a one-to-one function. So I'm just going to put here is not a function. All right, in example 3, so sometimes a formula of a function might be given, no graph, no order pairs. So how do we determine if something is one-to-one? Back to the definition, right here. To determine it algebraically, we're going to base on this. If f of a is equal to f of b, then a is equal to b. If we can prove that, then the function is one-to-one. So let's apply it to this one. So let's say I have I'm just going to write down first, f of a equals f of b. Our goal is to see if a is going to equal to b. Okay, so f of a, using this function, I substitute a in for x. So I have 2a minus 3 on the left side. And then on the right side, very similar, I substitute b in for x. So I have 2b minus 3. All right, I see that negative 3 on both sides. So I can add 3 to both sides to cancel them out. So I am left with 2a is equal to 2b. If I divide both sides by 2, where 2 and 2 cancel here and 2 and 2 cancel here, I'm left with a is equal to b. So I was able to show that if f of a is equal to f of b, then a is equal to b. Therefore, we can conclude that this function is one-to-one. So I'm going to say yes here. Second example. So again, let's start with writing just f of a equals f of b. Let's see if we can conclude a is equal to b the same way in part A. So first, we substitute a in for x, so we have a squared plus 1. On the other side, we have b squared plus 1. 1 is on both sides, so we're going to just cross 1 out. So we're left with a squared is equal to b squared. Now, to get a by itself, you need to take the square root of both sides. So when you take the square root, you get a is equal to plus or minus b. The square root and the square cancel, but you're left with plus or minus b, because technically when you take the square root of a squared, you get absolute value of a, and absolute value of a is equal to b, so then, or equals to absolute value of b, so then a is either positive b or negative b. You have a is equal to b, but also a is equal to negative b. So we couldn't exclusively show that a is equal to b, therefore, this is not a one-to-one function. So if you were to graph, we recognize that the function in part B here is a quadratic function. So that means it must have a parabola as the graph. So if you were to draw a parabola, and then if you were to do the horizontal line test, as you can see, it doesn't pass the horizontal line test, so it can't be one-to-one. But that's just to confirm our answer.